right, so I'm getting ready to set up the reaction for the structure determination experiment. I'm starting with 2,3-dimethyl 2,3-butanediol, and I'm treating it with sulfuric acid and heat, and I'm not sure what I'm going to get. In lecture, we talked about doing a dehydration. Because we have two alcohols, are we going to get a double dehydration? We're going to have to figure that out. So this is the general setup, and I have the general procedural information in my notebook. And then I have the glassware laid out to make sure I have everything I need. So I have all the materials that I need: graduated cylinders, water, the 2,3-dimethyl 2,3-butanediol, concentrated sulfuric acid, the boilizers are the boiling stones, and then for later, the magnesium sulfate. So I've got all the reagents in here. I have the heating mantle. There's just a teeny tiny bit of space. We want it to be close enough so that the heating mantle can heat the glass, which can heat everything inside, but we don't want it to be pushing against it. We've got joint clips. This is securing the condenser. Another joint clip here, and then it will drip right into whatever distills off, will drip right into this centrifuge tube. Okay, so you can see the condenser fill up from the bottom. So right now you can see that the water's flowing pretty fast. We don't need it flowing that fast the whole time, as long as it stays cool. So I'm going to turn this down just a little bit. And then I tuck the tube a little bit down the drain so it doesn't pop out. And that should be secure. I also put, if you can see, these little wires to wire on the tubing to make sure that the rubber tubing doesn't pop off of the condenser. So now we're ready to start heating. So we have our heating mantle, and we plug this in not directly to an outlet, but to a variac. If you were to plug a heating mantle directly into a wall outlet, that is too much power, and you can't control the temperature either. We double check that we've got everything set up the way it should be, and now we can turn on the variac. Typically, you don't know how much you're supposed to turn on the variac. If you were to use the same one week after week, you would have an idea of what power you need to get to what temperature. Basically, start kind of low. So I'm going to start it at maybe 30%. Check after a few minutes. Check if your heating mantle actually is starting to warm up. You don't want to be heating for an hour and then find out that your heating mantle wasn't working, and so you haven't been heating for an hour. And now we just watch and wait. We will keep checking that our condenser is staying nice and cold. That means that we've got our water flowing through at a good enough rate so that whatever boils up here will condense here and then collect out here. So now everything's set up, the variac is working, and the heating mantle is starting to heat. And so we're just going to slowly keep adjusting the heat until we get this to start boiling. And then we're going to watch, we're going to see evidence of some condensation up here, and ideally we want it to be dripping out here. It uses the simple distillation glassware, but it actually is a steam distillation, so we can collect that pretty fast. So I'm going to record in my notebook the exact time that the reaction started. I already recorded the exact mass of starting material that I used, and I corrected. I had written down to add 3 mils, but it was supposed to be 3 grams of the 2,3-dimethyl 2,3-butanediol. So I corrected that in my notebook as well. So now we watch and wait and check for observations and clean up anything else that we can as we're waiting. So now we can see that the reaction is starting to boil nicely. You can see some condensation and then dripping back down right around the thermometer. And then if you look carefully, you can see sometimes some water dripping, liquid dripping down the length of the condenser. And then you can see drips forming at the tip and then dropping into the centrifuge tube, and you can see a little layer of liquid. Okay, so our reaction has been cooking nicely. It's still boiling, but it's not quite doing the same as what it has been doing. Notice when we look at our collection flask, we can clearly see there's two layers. So at first it was just overall cloudy, and then when you got enough, it separated into two separate layers. But now, watching the other droplets that come off, sometimes they looked a little bit oily, but they don't really look oily anymore. It just looks like it is clear water that's coming over. So I think I am going to stop the reaction. So while this is continuing to cool down, I put another flask there just in case there's any drops still coming off. But I want to start on the workup. So here is the vial, the centrifuge tube that contains both layers. I have two test tubes labeled. One is aqueous, one is organic. So I am going to try to draw out the bottom layer. Okay, I didn't quite get all of it, but if I check what is in the pipette, I can see that it is only the nice clear bottom layer, not the cloudy top layer. So I'm going to try again to get the rest, to get the rest of it. And let's see. Again, if I look in the pipette, I just have the clear water layer. Now that looks good. So I'm going to then pipette out the rest of this into my other labeled test tube. This is the organic layer. Now, normally when we have a mixture of aqueous and organic, we don't always know what's on top or what's on the bottom because we have to know the density of the different layers. In this case, we are told that the aqueous layer is on the bottom. Okay, so even though it looked like I got all of the aqueous out, now as I'm drawing up the last bits, I still have some aqueous in here. So what I'm gonna do is let it separate in the, I'm looking at it and I'm not showing you. I'm gonna let it separate a little bit so we can see that down here is the clear liquid. So that is going into the aqueous, and then the rest of the cloudy stuff is going into the organic. Okay, so now I have my organic layer all in this test tube, and I have some magnesium sulfate. So this is a drying agent. This is going to absorb any last bits of water that we can't see. If you can see any droplets of water in here, then you definitely want to remove them by pipette. But even when it looks like you have everything out, there's still some microscopic traces of water. So we add in a little bit of mag sulfate. And then we shake it up, okay? Now, when mag sulfate absorbs water, it is going to get really clumpy. And if there is some magnesium sulfate that doesn't absorb water, then it's going to stay nice and free flowing. Okay, so right now we can see that all the mag sulfate is clumped. Okay, so that means that it's all absorbed water. We don't know if it's got all the water or if it's just ran out of mag sulfate, if it's at its capacity. So because we don't see any free flowing, we need to add a little bit more. Okay. Again, I'm going to mix it up, give it some time to do its thing. Okay, so now when I shake and then I stop, you can still see some mag sulfate that is floating around. Okay? I mean, it does settle quickly, but still, it's not clumped. It is free flowing. So that means it must have absorbed all of the water that's in there, and then the remaining bits of mag sulfate, they remain free flowing because they have not absorbed water. So that means our organic layer should be nice and dry. So we can pipette out, or we can filter our organic layer into a clean, dry, pre-weighed container so that we can figure out the weight of our product.